Welcome back to the chemistry class. We were dealing with the chapter Haloalkanes and Haloarenes. Already we have discussed about the definition of haloalkanes and haloarenes in the previous class. Then we have studied the classification of haloalkanes based on the number of halogen atoms and based on the hybridization state of carbon in the carbon halogen bond. Then we have also discussed in the previous lecture about the nomenclature of haloalkanes in the common system and in the UPAC system, how we are going to name the haloalkanes. So in today's class, we'll be dealing with the nature of carbon and halogen bond and then methods of preparation of haloalkanes. We know that halogen atom is bonded to the carbon atom, and among carbon and halogen, halogen is more electronegative element. So as halogen is more electronegative, any atom, if it is having capacity to withdraw the shared pair of electrons towards itself, bonded pair of electrons towards itself, then it is said to be more electronegative, right? So among carbon and halogen, halogen is the one which is having capacity to withdraw the shared pair of electron, that is bonded pair of electron. Whatever the electrons are present here between carbon and halogen bond, those are moving towards halogen atom, as it is having that capacity to withdraw electrons on itself. So because of which this halogen atom now gets the partial negative charge, as the bonded electrons are lying more towards the halogen atom. Being more electronegative, it withdraws electrons more towards itself. So halogen atom carries partial negative charge and carbon gets partial positive charge, and because of this charge separation, this bond, that is CX bond, is considered as a polar covalent bond. It's a polar covalent bond. Okay, now if we see different examples of different halides, that is if we take methyl fluoride, methyl chloride, methyl bromide, methyl iodide, among them how there is a variation in the bond length between carbon and halogen, what about its bond enthalpy, and how the dipole moment varies down the group, that we'll see. See, look at this table. You can observe that from C, that is from when you move down the group, there is a bond between carbon and different halogens, that is varying from fluorine to iodine, right? So the bond length between carbon and fluorine is 139 picometers, whereas carbon and chlorine is 178 picometers. Carbon and bromine is 193 picometers and carbon and iodine is 214 picometers in this particular compound. This is the bond length of these bonds. Okay, and as you move down the group, the size of halogen is increasing. That's why the bond length is also increasing. Internuclear distance is going on, increasing down the group. And as the bond length increases, the bond enthalpy will decrease. As the atoms are far away from each other, it will be easy to break the bond. So energy required to break the bond will be less. So that means carbon and iodine bond that can be cleared very easily, which is having less bond dissociation enthalpy. Bond enthalpy is very less, that is 239 kilojoules per mole. Whereas carbon and fluorine are strongly held, they are very nearer to each other. That's why bond length is very less, and because of which we are having more bond enthalpy. We need to add supply more amount of energy to break that bond. So here it is having highest bond enthalpy, that is 452 kilojoules per mole. If you go to the dipole moment, so what is dipole moment? Dipole moment is the product of charge and the distance between the two poles, right? So here the poles are positive end is carbon and negative end is halogen. So it is a product of dipole moment is the product of distance and the charge present on that particular group. So here dipole moment is varying. See how it is varying. Actually, the dipole moment has to decrease continuously. That is, highest should be present for carbon and fluorine. It should have highest dipole moment because fluorine is higher, having higher electronegative character. It has to decrease continuously. So highest dipole moment should be possessed by carbon and fluorine, but that is not the case. Look at here. the highest dipole moment is for CCl bond, not for CF bond. This is because this variation is because of this variation, exception is because of, as fluorine is having, though fluorine is more electronegative, it possesses higher negative charge, but the distance is very small. That's why the dipole moment is less compared to the CCl bond. In CCl bond, though chlorine is having less, it is not that electronegative compared to the fluorine. It is less electronegative than fluorine, but the bond distance is much higher than that of C and F. CF bond. So that's why that this one, the dipole moment of CCl bond is more than that of CF bond. Okay, so this is the nature of carbon and halogen bond in different alkyl halides. Okay, now we'll move to the next part, that is methods of preparation of haloalkanes. The first one is from alcohols, that is alcohols are generally represented as ROH. Okay, so by the replacement of hydroxyl group by halogen, we are getting, by the replacement of hydroxyl group by halogen atom, we are getting alkyl halides or haloalkanes. So by the substitution, replacement is nothing but it is a substitution. So substitution of hydroxyl group by halogen results in the formation of haloalkane. So there are different methods of replacing this OH group from alcohol to get the haloalkanes. Now we'll see the first method of preparation of alcohols from halogen acids. That is, alcohols are converted to the respective haloalkanes by the treatment of hydrogen halides or halogen acids. That is, when alcohol is represented by ROH, when it is treated with HX, hydrogen halide or halogen acid, there is a loss of water, H2O goes out on reaction. There is a linkage between alkyl group and halogen. So this is how the reaction takes place. Okay, so alkyl halide is formed by the reaction of alcohol with hydrogen halide. If you are taking here different hydrogen halides, if you consider different hydrogen halides as HI, HBr, HCl, so among them, which shows faster reaction? Alcohol reacts with hydrogen halide to give alkyl halide. So which halide is formed at a faster rate? Hydrogen iodide will undergo a faster reaction to form iodides. Okay, so HI is more reactive than HBr than HCl because of the bond dissociation enthalpy, because this is having very less bond dissociation enthalpy, so it undergoes reaction at a faster rate. So this is the reactivity order of, hydrogen halides. Okay, so if I keep here HX constant, if I take here HCl, HBr or HI, if I take any one hydrogen halide as a constant, and if I go on change the alcohol present here, so what will be the change in the reaction? So which undergoes faster reaction and which will be the slower reaction? So here if you take different alcohols, the rate of reactivity of different alcohols towards this reaction follows this order, that is tertiary alcohol undergoes reaction faster rate, then secondary alcohol, then primary alcohol. So this is the reactivity order of alcohols towards nucleophilic substitution or towards this substitution reaction. Tertiary alcohols show faster reaction, so it completes the reaction at a faster rate compared to secondary and primary. Okay, so this is an example of nucleophilic substitution reaction which we'll deal later. Now we'll take examples in place of HX. So how we are forming chlorides, bromides and iodides. So if I take here alcohol, if it is treated with HCl, so there is a formation of chloride, as we have in X place we have Cl, so now H2O goes out and there is a formation of RCl bond and H2O goes out, right? So you are getting here alkyl chloride or chloroalkanes are formed from alcohol. So the reaction of HCl with alcohol takes place in presence of the catalyst, that is anhydrous zinc chloride. So anhydrous zinc chloride is acting as a catalyst in this reaction, so which helps in the cleavage of, in breaking of CO bond. Okay, so this helps in the breaking of this particular bond. Okay, so that's why it acts as it helps in the reactivity, to increase the reactivity rate of the solid, to increase the rate of the reaction, so it will be called as catalyst. So it helps in the breaking of carbon and oxygen bond. And if I take an example for this, CH3CH2OH, that is ethyl alcohol. This is ethyl alcohol. When it is treated with HCl in presence of anhydrous zinc chloride, there is a formation of CH3CH2Cl. OH is replaced by Cl, right? So you are getting ethyl chloride. Product formed here is ethyl chloride or chloroethane, right? So this is your primary alcohol. Okay, so if I take now another example, this is your secondary alcohol. OH group is attached to secondary carbon. Again treat it with HCl, and here also you need to add the catalyst, that is anhydrous zinc chloride. So there is a formation of, what happens, OH is replaced by Cl. So you are getting product CH3, CHCl, CH3 plus H2, right? So this is propane to all gives 2-chloropropane. So you are getting 2-chloropropane as a product, right? So now this alcohol is secondary alcohol, right? So primary alcohol and secondary alcohol are reacted with HCl in presence of anhydrous zinc chloride, gives respective chlorides. Okay, and among them this appears only after heating, that is primary alcohol gives this particular product only after heating. So usually whenever chlorides are formed, they are forming white color precipitate, white turbidity will be formed. Chlorides are having white precipitate or white turbidity formed. So whenever chlorides are formed, you are getting white PPT there. So this PPT appears only after heating in case of primary alcohol. Okay, whereas in case of secondary alcohol, after mixing, after 5 to 10 minutes, you will get the white precipitate. Or that means if you are observing white PPT, means this product is formed. Okay, this is the case in the first primary alcohol and secondary alcohol. If I take tertiary alcohol, if I take here tertiary alcohol, what happens? See, if I take tertiary butyl alcohol, if I take here this one, here I'll take tertiary butyl alcohol. So if this one is the reactant, which is tertiary alcohol, on reaction with HCl, it results in the formation of tertiary butyl chloride, that is OH is replaced by Cl with the release of H2O. Okay, and here no need of any catalyst. Okay, even no need to heat also. At room temperature only the reaction takes place. Immediately as soon as you add HCl to this, you will get white turbidity of tertiary butyl chloride. So this reaction is a faster reaction. I had told earlier that tertiary alcohols are showing faster reactivity. They are more reactive. So this is the illustration for that. Okay, so tertiary butyl chloride is formed immediately. Okay, no need of catalyst in this particular reaction. So this is how HCl reacts with different alcohols to give the alkyl chloride. Similarly, bromides and iodides are also formed by the reaction of alcohol, with the hydrogen halides, but here the difference is we are not taking directly HBr, as it is not that stable, it is not stored in the laboratory. So instead of taking HBr, we are taking NaBr and H2SO4, sodium bromide and sulfuric acid, with alcohol. These two will react to form HBr and NaHSO4, which is formed in situ, which further reacts with alcohol to form respective alkyl bromide. Okay, similarly even with HI also same thing, we are not taking HI directly, instead of that we will be taking potassium iodide and the phosphorus acid, which will react with alcohol to form respective iodide. So this is how hydrogen halides, halogen acids will react with alcohols, different alcohols. Okay, next is by the action of phosphorus halides, alcohols on reaction with phosphorus halides. Here we are taking phosphorus pentachloride and phosphorus trichloride. Okay, so first we'll see what happens when it is treated with phosphorus pentachloride. So alcohols on reaction with phosphorus pentachloride results in the formation of OH is replaced by Cl, and we are getting the byproducts POCl3 and HCl. These are the byproducts in the reaction. Okay, so this CH will be combined with one Cl to form HCl and remaining part with oxygen to form POCl3. So this is how we are getting alkyl chloride. Alcohols on reaction with phosphorus pentachloride gives alkyl chloride, phosphorus oxychloride and hydrogen chloride. And if you want example, CH3 CH2OH, this is ethyl alcohol. When it is treated with phosphorus pentachloride, there is a formation of CH3 CH2Cl plus POCl3 plus HCl. Okay, so this is the example. Similarly, even chlorides are prepared by the alcohols even by the reaction of PCl3, that is phosphorus pentachloride. Okay, sorry, phosphorus trichloride. So alcohols on reaction with phosphorus trichloride, there is a formation of alkyl chloride and phosphorus acid. Okay, here we need 3 moles of alcohol, so that it will result in the formation of 3 moles of alkyl chloride and the phosphorus acid is formed as a byproduct. If you want, you can write the reaction example, that is 3 moles of methyl alcohol, methanol, on reaction with phosphorus trichloride, there is a formation of 3 moles of CH3Cl and phosphorus acid. Okay, so this is how the reaction takes place. Here, not only chlorides, even bromides are also formed, but the phosphorus tribromide, that is PBr3 and Pi3, are not that stable. So they are prepared by the action of red phosphorus with bromine or red phosphorus in iodine. So if you want this particular reaction directly in this PCl5 place, we can't take PBr3. Instead of that, what we have to take, like this. I'll take an example, C2H5OH. If you want to convert into bromide by using this phosphorus reagents, then you need to take here the red phosphorus in presence of bromine. So first, this will react, this is red phosphorus, this will react with 6 moles of Br2, results in the formation of 4Br3, 4 moles of phosphorus tribromide is formed. Now this PBr3 is taken for further reaction, that is CH3OH on reaction with PBr3, it results in the formation of CH3Br plus H3PO3. Okay, similarly for Pi3 also, you have to react phosphorus with red phosphorus with iodine which results in the formation of phosphorus triiodide, which reacts with alcohol to form respective iodide. As they are not stable, it will not be ready. So whenever we require it, we have to prepare it by using this particular combination. And phosphorus pentabromide and phosphorus pentaiodide are not existing only. Okay, so this is how alcohols react with phosphorus halides to form respective alkyl halides. The last and the most convenient method for the preparation of chlorides from alcohols is by the action of thionyl chloride, that is SOCl2. SOCl2. This is how this is the structure of SOCl2. So whenever alcohol is treated with thionyl chloride SOCl2 in presence of pyridine, this is a base used in this particular reaction. So there is a formation of, when it is treated alcohol and thionyl chloride, there is a formation of alkyl chloride with the release of sulfur dioxide and HCl gas. So here, this is, as I said, it's a most convenient method for the preparation of alkyl chloride, as the products are escaping out as gases. So no need to separate it again. So separation is not required. Further separation of the products, you are getting separated, or almost in the pure form, it is free from the byproducts. So this is more convenient method of preparation of alkyl chloride. Okay, so here pyridine is a base used in this particular reaction to neutralize the HCl formed in the reaction. So pyridine is nothing but C5H5N. This is the base pyridine used in this particular reaction. For example, you can write the example: C2H5OH ethanol on reaction with thionyl chloride in presence of pyridine results in the formation of C2H5Cl, SO2 and HCl. Okay, so this is how the reaction takes place. Next method of preparation is from hydrocarbons. In that, first one is by free radical halogenation of alkenes. This you have already studied in the PO1 classes. That is, when methane is treated with chlorine in presence of sunlight, there is a formation of CH3Cl and HCl, right? So hydrogen is substituted by Cl. 1H goes out and in that place Cl comes. So methane reacts with chlorine in presence of sunlight, results in the formation of methyl chloride or chloromethane. If you have the same reaction condition, again it will continue. So further CH3Cl will react with the chlorine to form C2, that is CH2Cl2, right? So like this it continues until all the hydrogens are replaced by Cl. This is the case when we take methane, as it is having same type of hydrogen. If you take here propane instead of methane, if I consider propane, this on reaction with chlorine in presence of light, or you can heat it at 298 Kelvin temperature. Okay, so what happens? Hydrogen will be replaced by Cl, right? So this is a free radical mechanism which you have studied last year. So hydrogen is replaced by Cl. Here we have two types of hydrogens, that is, this is your primary hydrogens. We have 3 primary hydrogens and 2 secondary hydrogens are there. So in one case you will be having replacement of middle hydrogen. So there is a formation of 2-chloropropane as a product, and also you will be having another product, that is CH3CH2CH2Cl, that is by the replacement of this hydrogen, primary hydrogen, also you get one product. So in this particular method we are getting mixture of compounds as a product. This gives 1-chloropropane, 2-chloropropane and 1-chloropropane. Okay, so we are not getting single compound. For that we need to maintain certain conditions. So we will be getting different mixture of different compounds depending upon the number of available hydrogen types. Okay, So this is the free radical mechanism, free radical halogenation of alkenes. Even instead of chlorine, you can also take bromine or iodine, but there the conditions are different. Okay, we need to maintain different conditions. We need to add oxidizing agents in case of iodination to avoid the oxidation of oxidation. So certain conditions you have to apply, then only we get the required product. This is just an example. Next is from alkenes. From hydrocarbons means we are preparing here haloalkanes from alkene, alkenes or alkynes. So now we have studied about alkenes. Now next we'll go to the preparation from alkenes. From alkenes. In this again we have two types, that is by the addition of hydrogen halide. By the addition of hydrogen halide to the alkene. Okay, so whenever we have multiple bond, it usually undergoes addition reaction, right? So I'll take directly an example. Alkenes, this is ethene. Okay, so when ethene is treated with HX, here I'll take HI or HCl or HBr. Okay, so if I take here HCl, what happens? Addition reaction takes place. One hydrogen goes to one carbon, remaining Cl goes to another carbon. Addition reaction takes place here. So CH2H, CH2, Cl. So whenever addition reaction takes place, double bond will convert into single bond. These particular species will go and add to the respective carbons, right? So what is the product formed here? It is CH3, CH2, Cl. So I'll write here as CH3, CH2, Cl. Single compound is formed as a product in addition reactions. Similarly, if I take propene, this is propene. When it is treated with HBr or HCl, now the case comes, now the condition comes here. See, we have now, in this case, both the carbons are same. So either you add H here on this side or this side, you will get single compound, ethyl chloride as a product. But if this is the case where we have one carbon atom to this doubly bonded carbon this side, whereas this is not having any carbon atom. So this is considered as unsymmetrical. This is unsymmetrical alkene. So when unsymmetrical alkene is there, whenever we are adding unsymmetrical molecule, that is unsymmetrical means both are different atoms, right? It's made up of two different atoms. So whenever such addition is taking place, we have to follow which rule? Markovnikov's rule. You have studied this, right? Markovnikov's rule we have to follow. So what this Markovnikov's rule says? Markovnikov's rule says that whenever we are adding unsymmetrical alkene to the unsymmetrical molecule to the unsymmetrical alkene, negative part of adding molecule goes to the carbon containing less number of hydrogen atoms. So whenever unsymmetrical molecule is added to the unsymmetrical alkene, we have to follow Markovnikov's rule. So what the rule says? Negative part of the adding molecule. So in HBr, which is the negative part? Br minus is the negative part. So this negative part goes to the carbon containing less number of hydrogens. So here the addition takes place across the double bond. This is the place where the addition has to take place. So among these two carbons, the one which is having less number of hydrogens, that will get this Br. So that means Br goes and attacks to the middle carbon atom. So see, in HBr negative part is Br, H plus Br minus. So Br goes to the middle carbon, double bond will convert into single bond. Now remaining part attaches to remaining carbon atom, that is CH3. So this is how the reaction takes place according to Markovnikov's rule. This is the major product in the reaction. You have also studied the mechanism of this rule in the last year, correct? So this is how the addition takes place to form respective hydrogen halide. Okay, so here we have also studied about one condition of during the addition of HBr, only HBr to the unsymmetrical alkene, that is taking place in presence of peroxide. It may be any peroxide, hydrogen peroxide, benzoyl peroxide, any peroxide you can take here. So whenever the addition of only HBr, HiHCl will not undergo this reaction, only HBr addition to the unsymmetrical alkene, if it is taking place in presence of peroxide, it goes against the Markovnikov's rule. That is, it goes against the Markovnikov's rule means it undergoes anti-Markovnikov's addition. Anti-Markovnikov's addition against the Markovnikov rule. According to Markovnikov rule, what you have to do? Negative part has to attack the middle carbon, which is having less number of hydrogen. Now it is going against the rule means this negative part has to attack this particular carbon against the rule. So we are getting the product CH3, CH2, single bond CH2, Br. So instead of going to the middle carbon, it goes to the last carbon. So this is the 1-bromo-propane. This is 2-bromo-propane. In this manner, the reaction takes place, right? So addition of hydrogen halide to the alkene gives you alkyl halides. So addition of unsymmetrical molecule to the unsymmetrical alkene goes according to Markovnikov's rule, or else you can add anywhere. If addition of HBr is taking place to the unsymmetrical alkene in presence of peroxide, it goes against the Markovnikov's rule, that undergoes anti-Markovnikov's addition. So this is how we are getting alkyl halides from alkenes by one method, that is by addition of hydrogen halide. Next is from alkene. Next method from alkenes is by the addition of halogens. By addition of hydrogen halide, we get only one halogen gets attached to the alkyl group. When we are adding two halogens, that is when we take a molecule of halogen, that is if I take an example of ethene, this is ethene, when it is treated with halogen, it may be any halogen, chlorine, bromine, iodine. So whenever halogen is treated with alkene, the addition takes place, results in the formation of vicinal dihalide, that is two Cl atoms are there, one Cl goes to one carbon, double bond will convert into single bond and another Cl gets attached. So addition reaction always gives only one product, and unsaturation will convert into saturation. Remember these things in the addition reaction. Okay, so ethene reacts with chlorine, which gives 1,2-dichloroethane. So this is nothing but the vicinal dihalide. So what is meant by vicinal dihalide? Two similar halogens are present on the adjacent carbon atom, neighboring carbon atom. Okay. Similarly, I'll take another example. CH2 plus Br2, bromine. This usually takes place in presence of carbon tetrachloride, which acts as a solvent here. Okay. So addition takes place in this manner. One Br goes to one carbon, another goes to another carbon, double bond will convert into single bond. So we are getting 1,2-dibromoethane. If you take the propene, you will get 1,2-dibromopropane. Okay, so this is how addition of halogen takes place to give the halogenated compound, vicinal dihalides. And here remember this particular reaction, which is important. This is also called as test for unsaturation. This is one of the tests done to check the presence of multiple bond in the system. So what is meant by unsaturated compound? The compounds which contains double bond or triple bond between carbon atoms are called as unsaturated compounds. So to check the presence of these multiple bonds, we are carrying out this particular reaction, that is bromine water test. We call it as bromine water test, where the compound is taken, it is dissolved in CCl4 and bromine is added, bromine water is added. So the color of bromine will disappear. The color of bromine will discharge, that is color of bromine is it's reddish orange color, which will discharge, which will disappear if you add it to the unsaturated compound. Okay, so why the color changes, why the bromine orange color, reddish orange color of bromine will discharge? Because Br2 is having reddish orange color, but this is not having any color. So as it adds across the multiple bond, as it undergoes addition reaction, the color will not retain. As that moiety will not retain, the color will not retain. Okay, so this is, remember, this is important for again your viva, practical viva. So this is test for unsaturation. So this is how we are getting halides, that alkyl halides from hydrocarbons. Next method of preparation of alkyl halides is by halogen exchange method. In this we have two important name reaction. One is Fingerstin reaction, first one. This is important for examination, will be asked for 2 marks. So statement is alkyl chlorides or bromides on heating with sodium iodide in dry acetone gives alkyl iodides, that is alkyl chloride on reaction with, on heating with sodium iodide in dry acetone, on heating the reaction takes place. So it results in the formation of alkyl iodide. So what happens here, Cl and Na, this goes out as NaCl, there is a formation of alkyl iodide. This is the reaction. Similarly, even if you take bromide also, same type of reaction takes place, that is RBr reacts with sodium iodide NaI in dry acetone. On heating, NaBr goes out with the formation of alkyl iodide. Okay, so this is called as Fingerstin reaction. Okay, reverse of this is not possible. That is, after forming, you can ask, after forming alkyl iodide, whether it will react with NaCl to show again halogen exchange process. No, because NaCl, Na and NaBr, they are less soluble in acetone. So NaI is more soluble in acetone. So that's why further reaction will not take place, reversible reaction is not taking place, as they are less soluble in acetone and they get deposited, they get precipitated out as sodium chloride and sodium bromide. So reverse of this is not possible. So this is Fingerstin reaction. Very important for the examination. We call, it's a name of the scientist, we call such reactions as named reactions. So very important for the examination. For 2 marks they'll ask this question. So I'll repeat, alkyl chlorides or bromides, you need to mention both. Okay, you can't write generally alkyl halide, you have to write alkyl chlorides or bromides on heating with sodium iodide in dry acetone, it gives alkyl iodides. For example, if I take CH3, CH2Cl reacts with NaI in dry acetone, on heating gives CH3, CH2I plus NaCl. This NaCl will go out, CH3, CH2I. So we are getting here, this is ethyl chloride. Ethyl chloride gives ethyl iodide. You can also write your pack names, no problem, chloroethane or iodoethane. Okay, so similarly you can take Br in place of Cl. This is an example for Fingerstin reaction. Next halogen exchange method is Schwarz reaction. So the definition of Schwarz reaction is alkyl fluorides can be prepared by heating chloro or bromoalkenes with metallic fluorides such as silver fluoride, mercury fluoride, copper fluoride, antimony fluoride, etc. So here this is also very important for the examination for 2 marks, or they'll give reaction. You have to name the reaction, that will be asked for 1 mark. You need to complete the reaction, so such questions will be asked for 1 mark. So the definition of Schwarz reaction is alkyl fluorides. Statement of Schwarz reaction is alkyl fluorides can be prepared by heating chloro or bromoalkenes with metallic fluorides like these. So for example, if I take here bromomethane or methyl bromide, when it is treated with silver fluoride, anyone you can take, not all, anyone you take. So what happens? Halogen exchange takes place, that is, in place of Br you will get F, and in place of fluorine you will get Br. So you are resulting in the formation of fluoromethane, and the byproduct is AgBr. So exchange of halogen takes place. Okay, in previous also same thing was happened, exchange of halogen takes place. Okay, but it is particular. You need to take their chloro or bromoalkane. You can't take iodoalkane, or you can't take fluorine again itself. Okay, so this is one example. Similarly, I'll take another example where I'll take 2 moles of ethyl chloride. When it is treated with Hg2F2, what happens? See here, there is a formation of Cl is replaced by fluorine. So I have taken 2 because here we have 2 fluorines. So what happens? So it is used to replace 2 molecules of chloroethane can be used here to get fluorinated compound. So results in the formation of fluoroethane. So exchange of halogen takes place. So you can take Cl or Br, which will be replaced by fluorine. Okay, so this is Schwarz reaction. Okay, in these reactions you need to mention those halogens are chloro or bromo. You need to, when you are writing the general equation, you have to mention Rx and whatever the reagent it may be. In Fingerstin it is Ni, whereas in this case if I take here AgF in general, okay, this is Fingerstin reaction, Fingerstin, and this is in case of Schwarz reaction. Okay, so general reaction, if you are writing for this is in presence of acetone on heating. Okay, so you are writing Ri plus CnaX. In this you will be writing Ref plus Agx, right? So here you need to mention in these general reactions X is Cl or Br. It's compulsory to mention the Cl or Br. In example you will be writing, but in general reaction you have to mention that X stands for Cl or Br. Any other halogens will not undergo this particular reaction. Okay, remember this one. These 2 are important, very important reactions for the examination. The named reactions, their statement, and the general reaction and example. Okay, so in today's class we have discussed about the nature of carbon and halogen bond and the methods of preparation.